Live. Oh, hello. Welcome to the stream, and I haven't got the chat up. How y'all doing? Hopefully pretty good. Uh, it's the reading group, and this is actually going to be the last reading group of the year, unfortunately. Well, maybe not unfortunately. I think it's fine. But that means that we are actually only going to be back with live streams starting the second week of January, because I'm doing other work stuff the first week of January in this time slot. So let's get into it. The paper that we're reading today is from actually a conference I've never been to or heard of. Well, I guess I've heard of it. I guess I've seen other papers from it, but it's slightly adjacent to the ACL conferences. It's an IEEE conference, so the International Association doesn't start with an E. I always assumed it was association. I don't know why. It's the big electrical engineering professional organization, much bigger than ACL, which is the computational linguistics organization. And it was published in 2019 at the first international workshop on bots in software engineering. So specifically, this workshop was focused around people who are building, text assistants, hi Gerard, for software engineers to help them do their job. More coffee. Sorry, I've already been focusing a lot this morning, so I'm a little bit brain tired. And the paper is by Chris Brown, not that one, and Chris Parnin from North Carolina State University. So let's get into it. The paper is called Sorry to Bother You, Designing Bots for Effective Recommendations. Chart says Institute of Electrical and Electronics Engineers. Thank you. I don't know why I just looked at the acronym and made up some things that went with it that was not the thing that it is. But very big professional organization, very prestigious conferences. All right, abstracts. Looks like it's a little small, so I'm gonna bump it up a little bit. Why are you saying? Are you having trouble on? So I know that yesterday for the office hours, I was having some problems. I think what's actually happening is my voice is being noise suppressed. So I could talk about it a little bit because it is, I guess it does count as electrical engineering. So I use Streamlabs OPS as my encoder software, and they recently introduced a new RNN-based noise suppression. And I think that it might actually be suppressing some things that are signal, to wit, my voice, and that might possibly be what's happening. So I have adjusted it a little bit, but let me know if I'm still fading in and out. Am I going to publish any paper in ACL? I've published quite a few ACL papers. So this year, Vincent and Thomas, I think it was Thomas. What was it? I don't think it was Tobias. I think it was Tomas. I should know. We worked on this together, but mostly online. Published a paper in the NLP OSS workshop at EMNLP. Yeah, I think it was EMNLP and not EACL. But yes, I have published quite a few papers. It's just I'm not a researcher primarily anymore. Hi, Enrique. And yes, I picked up the explanation. Thank you. Abstract. Bots have been proposed as a way to encourage developer actions and support software development activities. Many bots make recommendations to users. However, humans may find these recommendations ineffective or problematic. So I guess a good example of that would be, if any of you ever used Microsoft Word when there was like Clippy, it was like a little animated paper clip, it would pop up and be like, it looks like you're writing a letter, I formatted it for you. And if you weren't writing a letter and it formatted it for you and you didn't enjoy the formatting, you had to go back and undo it, and it was just annoying. In this paper, we argue that while bots can help automate many tasks, ultimately bots still need to find a way to interact with humans and handle all of the associated social and cognitive problems entailed. To illustrate this problem, we performed a small study where we generated 52 pull requests making tool recommendations to developers. As a result, we only convinced 2 developers to accept the pull request, while receiving several forms of feedback on why the pull request was ineffective. We summarize this feedback and suggest design principles for bot recommendations, including how psychology frameworks such as nudge theory can be used to improve human-bot interactions. So basically, this paper is going to be talking about some things they tried that didn't work and how you can maybe do better. And nudge theory, I'm only sort of peripherally familiar in it. I haven't read a lot about it, but the idea is that like small reminders at the right time can help people change their behavior for the better. So a good example is if people are going through a cafeteria line and you're like, oh, we want people to eat more vegetables, you might put the vegetables first, right, in the cafeteria line. So as people are going through, they get to that first and they sort of load up their plate with veggies first. Would just be an example. Okay, voice is fine. Okay, good. I'm glad the futzing helped. Yeah, let's get into the introduction. Software robots, or bots. Software robots, I guess they are, huh? Are useful for automating a variety of tasks and can improve efficiency and effectiveness. However, their interactions with humans can be inconvenient due to limited responses from rule-based reasoning and poor UX design. And I will say, Rasa, in particular, we don't use rule-based reasoning for what to say next. Rules are but one, crayon in our crayon box, and most of the crayons are transformer-based models. For example, software developers found bots relevant and useful for automatically running tests, but they also reported facing numerous challenges, such as poor decision support and non-comprehensive feedback. Poor interactions between humans and bots can lead to negative responses towards automated suggestions generated by bots. Yeah, definitely true. For instance, users express more inappropriate language and negative emotions in conversations with Cleverbot compared to humans. Oh, I haven't thought about Cleverbot in a while. So Cleverbot was like an early sort of like chit-chat bot. So chit-chat is the task of just general topics of conversation. Yeah, and that must have come out while I was in undergrad, maybe? It was a while ago. So Cleverbot's been around for a while. To understand the impact of and then there's a link to Cleverbot, and then this chatbot.fail. So I'm guessing this is a collection of examples of poor chatbot UX design. To understand the impact of poorly behaving bots on humans, we create a naive telemarketer design, where a bot delivers actionable and technically sound recommendations to software developers. However, all interactions are static. In many ways, our design is like a telemarketer, calling users to deliver a static message. So it's just like some text, they deliver the same text. However, the interactions never deviated from the script and lack the social intelligence required to adjust the message or respond to questions. With this simple design, our goal is to initiate and then identify reactions from software developers. Future bots could then be designed to account for these interactions with users. So I think one way that you could improve on this, I mean, it sounds like they have intentionally built a very bare bones bot in order to sort of intentionally create kind of mediocre interactions. But one way that you'd be able to pretty dramatically improve this right away would be to use a framework like Rasa that allows for flexibility in choosing responses. To contextualize our design, we develop a bot, tool recommender bot, which makes tool recommendations to software developers by automatically configuring a software project to use the tool. Using development tools, such as static analysis tools, to automatically check for programming errors in source code is a useful behavior for developers to adopt for improving the quality of their work. For example, software engineers at Google use the static analysis tool Find Bugs to find thousands of warnings in their code. Despite the benefits of using static analysis tools, software engineers do not often use them in practice. I would agree with that last bit. In this study, we seek to explore designing bots as recommender systems to improve the tool adoption process in software engineering. So a recommender system is like Netflix is like, you might like this movie because you watch these other movies. So looking at, things that you've done and picking something for you to do or suggesting something for you to do based on your past actions. Or the actions of people that are like you in some important way. So like Spotify does a lot of work with songs that are put together in the same playlists. If you like songs in some of the songs in a playlist, you'll probably like the other songs in the playlist that was curated by people. If that makes sense. I think I probably didn't explain that in the best way. We evaluate pull requests made by Tool Recommender Bot and categorize the responses from software developers. Our results suggest that bots with simple technical knowledge alone are ineffective in influencing human behavior. Tool Recommender Bot was only able to make 2 successful recommendations out of 52, 4%. Analyzing these responses, we found that Tool Recommender Bot lacked the social context required to interact with users and understand the contextual factors to make effortless integration into a project's development workflow. All right, so basically this is saying that like I'm sure they'll go into it in more detail, but there's like certain expectations when you make a pull request socially, and it sounds like this bot didn't have the flexibility to meet those expectations. Bobby says Netflix was free for a bit. Cool. To remedy this, we propose integrating concepts from psychology and persuasion theory in bots to improve human-bot interactions. For example, nudge theory is a behavioral science concept that examines simple ways to influence human decision-making and convince people to adopt certain behaviors. Long-term, we hope this research provides a baseline that future designs can surpass. So this is like a if you were proposing a new task, you'd probably want to do like a simple model that's like, this is a doable task, but it's hard. So they're providing that baseline model to improve on. Motivating example. Cassius is a software developer maintaining several popular open source Java projects on GitHub. He does not implement any static analysis in his repositories because he is unaware of tools that can analyze Java code to prevent bugs. I am also unaware of these, mainly because I don't work in Java. One day, he notices a new pull request on his repository similar to the one shown in Figure 1. Figure 1. So here is the pull request. Tool Recommend Bot wants to merge one commit to master. Looks like you're not using any error checking in your Java build. This pull request adds a static analysis tool, Error Prone, created by Google to find common errors in Java code. For example, running mvn compile on the following code would identify this error. The error is that you are running equality on strings, which I guess you can't do in Java. If you think you might want to try out this plugin, you can just merge this pull request. Please feel free to add any comments below explaining why you did or did not find this recommendation useful. Okay, I would say this is actually a pretty solid pull request. Like, it explains what it's doing. It's got some like nice code examples to sort of show you the intended behavior, and then it tells you what to do moving forward if you want to add it. And then also there's this little like polite request for additional information. So I would say that's a pretty well-designed bot conversation. I mean, it's not really a conversation. It's a pretty well-designed bot interaction. Reading the pull request comment, Figure 1a, he learns what the tool does and how to use it. He also views, this is literally what I just said, he also views a simple Java function with an example of an error reported by Error Prone. Then he realizes not only does the pull request present information about the tool, but it also automatically adds the tool by modifying the build configuration files. He just needs to simply merge the pull requests to add the static analysis tool to his repositories. Cassius merges the requests to successfully integrate Error Prone in his projects, preventing himself and other contributors from adding programming errors in the future. So it's like an additional layer of security. This scenario is an example of how bots can be useful for helping users adopt new behaviors. In this case, using a bot effectively automated tasks, such as updating the build configuration file, and was able to make recommendations on multiple projects more efficiently than manual suggestions. Hello, Habib. Tool Recommender Bot. Tool Recommender Bot is a bot designed to recommend software engineering tools to developers on GitHub. Our system suggests tools to GitHub users by automatically, sorry, I keep wanting to read this as automatically, modifying build configuration files and generating pull requests with the tools. Many companies use build systems to automatically integrate, compile, test, and deploy their software more efficiently. While this is not the only context in which software engineering tools can be used, it allows developers to easily integrate and run new tools within their normal workflow. So just sticking it into your CI/CD pipeline. Tool Recommender Bot generates automated pull requests because they are the preferred method for suggesting changes to repositories. I would agree. Have been used by bots in prior work, citation, and create actionable recommendations for users. I'm going to pop down to the citation. Can automated pull requests encourage software developers to upgrade out-of-date dependencies? From the IEEE Conference on Automated Software Engineering 2017. And actually, I've gotten some of these requests on my own repositories when there's a security update. They're like, hey, gotta update TensorFlow for security. Where were we? Our goal is for Tool Recommender Bot to be extendable to recommend a wide variety of software engineering tools to developers. The initial implementation for the study naively recommends error-prone to Java developers on GitHub by adding it to repositories that use Maven, a popular build automation and dependency management tool for Java applications. Tool Recommender Bot automatically adds error-prone Maven plugin to the project object model configuration file to run the tool when the code compiles. The source code for a bot is publicly available online. Okay, interesting. Again, I sort of like know vaguely about Maven because my husband's a Java developer, but it's not a tool I have ever used. Our naive telemarketer design for the study provides a generic message and a simple code snippet with a common Java error to show users sample output from error-prone, shown in Figure 1. This is not the best design for making recommendations, however. However, we implemented this naive approach to create a baseline describing how bots influence human behavior. Tool Recommender Bot uses a human presenting account to make recommendations based on research showing bots emulating human users are more effective. Oh, is this the study about online abuse? Human bot interaction on social Q&A website, Murgy et al. 2016. It might be. I talked about that on actually the very first episode of the podcast with Sariq and the second guest whose name escapes me. I only get to remember one name per item today, apparently. And that study showed that Twitter accounts that were human presenting, particularly that were human presenting as male, could, by making recommendations to not be, abusive online, could change user behavior. And I don't know if that's this study. I don't think it was an HCI study. I think this is a different one. Scroll back up. Anyway, so it is human presenting. So if we look at this, you can see that there's a profile picture that's like it's a little bit hard to see. It's a sketch of a person with a hammer. They've got a beard and they're just sort of like, bloop. And that looks like some sort of illustration from a book that is aged out of copyright and is in the public domain, if I had to guess. But it also looks like the name of the bot is Tool Recommender Bot, so I don't think they're, trying to defraud anyone. In our pilot, we quickly discovered bot accounts are ineffective after our original GitHub account for Tool Recommender Bot was flagged within hours of making recommendations. Aw. I guess I can see why that happened, but that sounds frustrating as a researcher. All right, methodology. Projects. To evaluate Tool Recommender Bot, we used open source software repositories on GitHub. We sampled projects from the RepairNator, I'm guessing, evaluation to use for our study. The projects we selected met the following criteria. Primarily written in Java 8, successfully compile with Maven, do not already use error-prone. Since error-prone can only analyze Java code, our evaluation was limited to projects written in the Java programming language. To collect projects that build with Maven, we checked to see if repositories contained a pom.xml file in the home directory, and confirmed that they could be validated and compiled before adding the plugin. We also verified the pom.xml file did not already contain the error-prone plugin to avoid making recommendations to projects that already use the tool and target developers less likely to know about it. So this, based on their sort of discussion of the way that this looks, they're doing it with open source public repositories. I think this would probably be a little bit more effective within a company. So if you had, in your private GitHub repo, if you had a tool that was like, you forgot to use error-prone, please add it here. I think that's A, would be less likely to be flagged as spam, and B, would probably find better adoption. Our evaluation consisted of real-world Java applications with varying functionalities, number of source code files, and lines of code. So different sizes, they did different things. Well, our evaluation focuses on open source projects. Recommendations from Tool Recommender Bot could receive similar reactions from developers of proprietary software in a large company setting. The list of projects used for our evaluation is available online. Yeah, I feel like, I don't know, I feel like I'm just more willing to accept input right away from people talking about work stuff than I am for like stuff that I'm doing for fun. I don't know. It is like a nice pull request though. I'm trying to decide if I would accept this. I probably would, yeah. If this were a pull request that were sent to one of my projects, I'd probably be like, yeah, okay, sounds good. All right, data analysis. FISA says, in the NLU data, how are the intent names labeled with the training examples? Is there some technique that labels them together? Oh, like bulk labeling for the training examples? Yes, I think Vincent has a video about that went out last week. So I just search bulk labeling Rasa, and that'll point you in the right way. And that's on our YouTube channel. We categorize tool recommendations from our bot as effective or ineffective based on the status of pull requests. Developers of projects that receive a recommendation have the option to merge the pull request into the source code, close the pull request without merging, or ignore the pull request by leaving it open. Merging the automated pull request from our system indicates an effective recommendation since the recommendee decided to adopt error-prone and showed a willingness to integrate the static analysis tool into the project's build configuration to check for errors. Closing or ignoring the pull request from Tool Recommender Bot implies an ineffective recommendation because recommendees did not attempt to integrate the recommend tool. So did they do the thing that the bot asked them to do? We gathered quantitative and qualitative data to examine the effectiveness of Tool Recommender Bot. We observed merged pull requests from Tool Recommender Bot to calculate the bot's rate of effectiveness. Additionally, we aggregated comments from GitHub users on pull requests to analyze how developers reacted to receiving a recommendation. In the pull request, we encouraged developers to provide feedback on whether they found the recommendation useful or not. Additionally, GitHub also allows users to provide feedback on pull requests and comments using emoji reactions. We analyzed responses and reactions to gather insight into how developers felt about receiving automated recommendations for a bot. So, based on their discussion here, it sounds like this is not a conversational system. So, if the continue link, I don't want to get too off track right now, but if you go to the Rasa YouTube channel and then look under recent videos, it should be like in the top 10. So it's not actually a conversational system, and I think one of the things they're going to probably talk about is if this had been a conversational system with the flexibility to reply to users and sort of provide them more information, perhaps, it might have been more valuable or more helpful. All right, let's see. Bot effectiveness. Out of 52 recommendations, only 2 were accepted by developers. The remaining were categorized as ineffective recommendations, 10 closed, and 40 never received any response. Table 1 presents the results of our preliminary evaluation. So most of them were ignored. 96% of them were ineffective. Of the 12 recommendations that did receive developer feedback, 83% were rejected by developers who closed the pull request. 2 recommendations were merged. However, in one case, another contributor created a GitHub issue because our pull request caused problems with the project build. Oh no. The changes made by the bot were then reverted in a later pull request, removing error-prone from the project. Even though the tool was eventually removed, we still categorize this an effective recommendation because the developer accepted the pull request to try the tool. Yeah, I think that's a it's a reasonable to call that a success, even if it didn't end up working for them in the long term. Developer reactions. Our qualitative data also shows developers did not find automated recommendations from our bot effective. I would say that patterns with the quantitative data as well. We found 24 comments made on 17 unique projects. Of the 24 total responses, 6 were automated comments made on pull requests that provided information to first-time contributors, requested contributing license agreement signatures, and presented code coverage updates. So little bot conversation, automated reply. We received 18 developer responses from 15 different GitHub users and no emoji reactions on the automated pull requests from Tool Recommender bot. I don't know, I feel like it's a little sad they didn't get any emoji reactions, but I suppose if you can tell it's an automated request, you're probably a little bit less likely to you know, go ahead and interact with it. There were 5 positive statements on the recommendations, including on pull requests that were not merged. LGTM looks good to me, good contribution. Thanks for sharing it. Those 2 are merged. Thanks for helping spread the wonderful tool that is error-prone. Error-prone itself is something I could see us adding. So it sounds like a couple of these folks were like, okay, I'm happy to know about this. Maybe I'll add it later on, but I'm not going to do it using this particular pull request. However, most of the feedback we received from developers was negative. We categorized the remaining comments into 2 main cardinal sins we committed in the design of our bot, which led to ineffective tool recommendations. A, formatting. One issue developers found with our automated recommendations was inconsistent file formatting. In some cases, the format of the modifications to the POM.xml file in our automated pull requests was different from the rest of the file in terms of whitespace. Oh no, such as indentation, tab length, and line breaks. Several developers noted this, providing responses such as, you messed up the formatting pretty bad, the automated tool messed up the formatting to an extent that I could not see it, the change removes quite a lot of important things from the POM file. Okay, so this is sort of the automated code addition is causing other issues. There were 5 comments mentioning the POM.xml file formatting. Despite P7's comment, we did not remove anything from the configuration file and only added the plugin to it. For our evaluation, we attempted to use a general format when updating the build configuration file for repositories, but did not exactly follow the format for each individual project, which prevented some developers from merging pull requests. So I think what they're saying here is, you know, if you want to make a good recommendation, check what people are already doing and then try to do that same thing so that they have to do, you know, as few changes as possible to do what you're suggesting that they do. B, breaking builds. Oh no. Another major problem participants faced was that adding error-prone often broke projects built in Maven. Ironically, this was primarily due to errors reported by the tool itself in the project source code. So error-prone tells you about errors, and by adding it, you suddenly find out about all your errors, and even though the tool is working as intended, if you are looking at a merge request and it's like, this merge request adds 50 errors, maybe you don't want to use it. Many comments were made regarding this, including the following. Given the number of errors, I think it would cause more harm than good, winky face. Introduced erroneous behavior to the build. Your PR breaks the CI. So your pull request breaks the continuous integration. 8 comments mentioned failing builds on recommendations from Tool Recommender bot. While we hoped integrating tools into build configuration would make them easier to adopt, we found that developers did not appreciate it when our changes broke the build with errors. This was a major reason users closed automated pull requests from Tool Recommender bot. However, not generating pull requests updating POM.xml files could lead to increased adoption friction. So friction is just sort of like how difficult is it to do something? Like if there's a lot of steps or you know, you have to do something difficult to cause something to happen, you're probably less likely to do it. So creating the automated update, their goal is to make it very easy for people to adopt the tool. All right, discussion. Wow, we are blazing through this paper. It is pretty easy to read, I would say, which is nice. Our results suggest that bots alone are not effective for influencing developer behavior. The majority of tool recommendations from our naive telemarketer bot design were ineffective, ignored, or rejected by developers. This points to a need for design changes and improvements in order for bots to make better recommendations. Based on our experience implementing and evaluating Tool Recommender Bot to impact human behavior, we propose design principles for researchers to consider when developing future bots. Okay, so they're saying, hey, we tried this, it didn't work great. Yeah, so thinking about this from a more conversational side of things, and we'll probably have to loop back in with this. If we are, let's say, building a chatbot that does the similar thing, you might want to, I had a thought and it's fluttering away like a beautiful butterfly. So you're building a chatbot, let's say you pop in a GitHub repository link and then it crunches for a while and then it's like, hey, I think adding this tool might be helpful, error prone, and then you have maybe like 2 buttons, one's tell me more, or 2 would be like generate an automated pull request. So it is like, it's definitely going to be less discoverable because people would have to opt into using the system, but it might be a good, like, you know, before you push to prod, maybe you get a little chatbot pop up that like walks you through the steps, particularly perhaps if it's a larger company and this is the first time you've used their CI/CD pipeline, and it walks you through the steps, and at each step it's like, hey, do you want to learn more or do you want to keep going? Here's like an automated thing that helps you out. And maybe it provides like links to the docs for different things so you can learn more about different tools. Yeah. Faisa says, what is sentiment in Rasa? So sentiment is basically a machine representation of how the person writing a piece of text felt. So usually sentiment will be something like positive, neutral, negative. So this sentence might have, the majority of sentences generally have neutral sentiment. This one might be slightly on the negative side. Sometimes sentiment can be things like specific emotions, so joy, anger, disgust, that sort of thing. And it's used generally to sort of figure out how people are feeling and react accordingly. So in chatbots, often if there's something with very negative sentiment, you might have an option for somebody to file a bug, or you might like be like, oh, I'm sorry you feel that way, or something like that. Sentiment is used a lot in text mining to, you know, sort of understand the way that a large body of text contains emotions. So like tweets about a brand, do people like the brand? Are people angry at the brand? What's going on there? It's sort of the general idea there. And then it's an automated thing. Robbie says, bots are not in progress. Computer vision systems work well. Yeah. Yeah, I've got lots of thoughts about computer vision. I would say in general, the class of problems that are considered important in computer vision are easier than the class of problems that are considered important in NLP. And that's my stance on the matter. So let's keep going through the discussion here. Okay, so we finished all this. Design recommendations for researchers to consider. Or, bot developers. A, social context. One disadvantage of the design of Tool Recommender Bot is that it lacks social context. We refer to social context as the practices and activities standard for interacting with developers and contributing to open source software. Examples include formatting guidelines, contributor license agreements, README and contributing files, identifying unmaintained projects, participating in conversations during code review, and more. And this is one place where conversational approach might work really well, particularly for these examples here where the reviewer is like, this introduces errors. If the assistant could be like, yes, working as intended, I've just identified existing errors that your current sort of pipeline was missing, I think that would have made this tool more effective, but also much more difficult to build. Furthermore, Wessel et al. Found developers faced challenges interacting with bots and desired improved social interactions and smarter bots when making contributions to open source software. So just better interactions. And I think this speaks to a really core issue in bot development, which is that if you are interacting with somebody using language, their expectation is going to be that the linguistic interactions they have are going to follow the pattern that they have established expectations for. So if you are designing a system where the interface is natural language, it will always be evaluated not by sort of like its relationship to other systems, it will be evaluated by its relationship to human language interaction, which makes it hard, and which makes it like the evaluation criteria of the users is always going to be pretty stringent. Like, does this work the way that, does this conversation go the way that it would with a human, or in at least a way that I can, follow along and agree that these are reasonable things to say? And a lot of, especially earlier chatbots, failed that pretty spectacularly. So, yeah. Anyway, language is hard. That's that whole footnote. One method to accomplish this is to provide better examples within the project context. P7 desired more details on how error-prone can actually help us and suggested we could attach a report with actual findings in our code base instead of just some generic example. So like, here's an error we found in your project and how this tool found it. Using relevant examples can contextualize tools and improve recommendations on projects. Another solution is integrating chatbots into automated recommendations to answer questions from developers about a proposed tool. For example, AnswerBot was able to successfully automate answering Java questions from developers on the Q&A site Stack Overflow. Okay, so they're suggesting, adding chatbots might actually be really helpful here when people have questions about this tool and want to learn more about it. And thinking about it in sort of more general format, relevant examples, I think particularly in chatbots where the exact thing the user is asking for is not available or can't be found, having a good way to recommend something similar could really hold a lot of water. So if you're trying to book a flight and like the exact flight that you want isn't available or is extremely expensive, but if you go forward or back one day, it becomes much less expensive, or like you could get a better seat, that might be a recommendation that the assistant can make and be like, hey, I noticed like you booked a lot of flights through the service. I know you like a window seat. You can't get it on this flight, but if you fly the next day, you can get it. And also it's $500 cheaper or whatever. That might be very appealing and feel very useful to a user, and also be like something that a human doing the same task would do, right? So, can we use sentiments in Rasa? Does Rasa support it? I think you need to do a custom component interaction. I don't believe we support it super out of the box, but I might search the docs for sentiment to confirm that. Let me put it this way: I haven't used it in Rasa. Uh, uh, Avi says, language is complex, basically. Computer vision is natural. If we speak simple language, then NLP will be very simple. If your system cannot handle the, actual user data that is being input into it, it is a bad system. And I will say, efforts to make human language simpler or more machine readable or more quote unquote logical have unilaterally failed. The only example I can come up with that actually did work was Hangul, which is the writing system for Korean, which a Korean emperor at one point was like, that's it. We're having a fantastic writing system. It is my favorite writing system, by the way, based like specifically on phonetic features and articulatory features. And like the characters are supposed to represent the position of the tongue and other stuff. But yeah, there have been a lot of attempts to try and make language fit more into sort of like this mathematical, logical idea of how language should be. And they don't work. You gotta work with what humans actually do and not what you think that you would like them to do. Which I think is something that the authors of this paper would definitely agree with. Developer workflow. Most users found Tool Recommender Bot interrupted existing processes, most notably by breaking builds, and were discouraged from merging pull requests from our system. Okay, so they were talking about friction. Doing the thing that you want the user to do here is going to make their job harder, so they're not likely to do it. While social context deals with user interactions, developer workflow refers to interactions with the code and software development practices. Several developers expressed additional information needs to impact their workflow. P3 desired to know if the bugs were worth fixing and how to configure the plugin so as to ignore false positives. P7 noted it'd be good to analyze the impact in terms of build time. And P17 asked, can you fix the errors reported by your tool in the build? Great question. Great, you found some errors. Please fix. I think that's very reasonable. Additionally, Johnson and colleagues found that Tool's inability to integrate into developer workflow is a key barrier for adoption. Yeah, and that's definitely, I think that's something that chatbots as well can struggle with if you're trying to build a tool that is hard to use or that doesn't, fit well into someone's existing working style. They aren't going to use it. To improve recommendations, bots should suggest tools without breaking existing infrastructure. One solution is to change how potential users interact with tools. For instance, rather than fully integrating tools with automated tool requests, allow developers to incrementally use them, i.e. modifying the error-prone plugin to report errors as warnings instead of compilation errors, or implementing a demo mode for users to try the tool in a sandbox environment without impacting builds. Oh yeah, we have like a little a sandboxy example on the Rasa docs now, the Rasa playground. So just a way for you to play around with Rasa and try stuff out and see what works without having to download or install anything locally. Another solution is to help developers further by fixing issues introduced in the build. For instance, the program repair bot Repairinator presents developers with patches for errors. Automatically fixing reported bugs can improve recommendations within developer workflows. Yeah, that is a heck of a pull request there. If someone's like, hey, I found a way to identify errors and also I fixed them all for you, I'd probably accept that pull request. All right, and a little bit of discussion about nudge theory. Psychology research studies many ways to, sorry, I read that as psychology research studies, and that is the wrong parse tree. Many ways to impact human behavior. One example of this is nudge theory, which examines any factor that affects how people make decisions without incentives or constraints. So without being like, hey, I want you to do this, but I'm not going to tell you you have to, and I'm not going to like make your life better if you do. I just want to sort of like change your environment, usually is how it's done, to, make it easier for you to make the decision I want you to make. Nudges influence common everyday decisions, such as encouraging people to recycle more, and much larger choices like improving civic behavior or reducing crime. So I think a particularly famous example of this, or I don't know that it's famous for everybody, but it's one that I've heard about a lot, is So there's some theme parks in the US called Disneyland and Disney World, and they are chock full of trash cans. And at some point, one of the employees, apocryphally, it's Disney himself, which I don't know is actually true, like looked at people who were carrying trash and saw how far they were willing to walk before they just threw it on the ground. Also, this was like many decades ago when I think littering was more common, and then put trash cans like just inside that range so that people were always close enough to a trash can that they were liable to get to a trash can before they got tired of carrying trash and threw it away. Littering is bad, don't do it. But like there were not penalties for, littering. There weren't like you deposit the trash, you get a candy sort of thing. It was just the environment was changed to make it easier to do the desired behavior. Using technology to send nudges in digital environments is referred to as digital nudging. For example, Fitbit digital watches encourage users to increase physical activity. We envision, when giving a developer who is unaware of a useful tool, using bots to digitally nudge developers to adopt the tool. To accomplish this, we propose researchers integrate concepts from nudge theory to improve how bots mesh with social context and development workflows when making recommendations. Robbie's brought up the Piraha stuff. I'm deeply familiar with the Piraha stuff. Yeah. I don't want to get into it. I'm aware. Thank you. If y'all don't know, my PhD is in linguistics. Yeah, no. Yep. To accomplish this, so they're suggesting, hey, nudge theory is this way of doing things. You might use some of these techniques to sort of like make it easier for people to do the things that you want them to do, like, conserve energy or whatever it is. Nudge theorists Thaler and Sunstein note nudges must be easy and cheap. However, we found that the naive telemarketer design was cumbersome and expensive for developers by avoiding interactions and complicating project builds. So they're saying, hey, this was not easy and cheap for people to do, so probably not a very good nudge. Designing bots to make easy and cheap recommendations can improve their effectiveness by showing the value of the tools simply and clearly. For example, with Tool Recommender Bot, we found modifying build configuration files was costly, creating additional build errors needing to be fixed. An example nudge would be notifying the developers about bugs reported by tools without impacting the build. To do this, our design needs to modify how recommendations are presented. Nudge theory suggests that location impacts decisions, i.e., placing healthier food at eye level encourages people to eat better. Instead of automated pull requests, making comments on lines of code with errors may simplify recommendations to users. Oh yeah, that's a good idea. Yeah, I like that. Analyzing more nudge theory examples and applying them to bot design can improve human-bot interactions for influencing behavior. Yeah, I think these are very solid recommendations for bot design in general. Conclusion. We implemented Tool Recommender Bot, a not very successful bot, which is fine, right? Not every research project has to be like, I did this and it's the best ever, and I spent so much money on it, just so much money on it. It's perfectly fine to be like, hey, I tried something and it didn't work, and here's what we learned from it and how you can use those learnings. A bot that recommends static analysis tools to developers using a naive telemarketer design approach. We evaluated our system by suggesting error-prone to GitHub users with automated pull requests. Our results show this approach is insufficient for making recommendations, ignoring social context and integrating poorly with development workflows. So, doesn't work great, probably not a good approach to adopt piecemeal, or whole meal. Whole cloth? Adopt all at once in the way that they do it. To make more effective recommendations, we propose using nudge theory to improve bot designs for impacting human behavior. So, an interesting study. I think definitely some big takeaways for developers who are, working on chatbots in particular. So one thing is make sure you're meeting the social expectations of the particular, interaction that you're having. Make sure that your suggestions, the things that you're trying to get people to do, is easy and cheap, and doesn't take them a lot of time. I don't know about location. So I think like the physical location of a digital nudge makes more sense with a GitHub bot than it does with a conversational assistant. But I guess it's like, where in the conversation is it happening? So I guess a good example of that would be if you had a chatbot and you have like 10 things that people can do with the chatbot, and 85% of people are always doing option number 3. One thing that you might do is, as the first turn in your conversation, have, a button response. I don't know, I'm really into buttons lately. Have a button response being like, hey, do you want to do the thing that everybody wants to do? Or do you want to do something else? And then diverting the majority of people who have this thing that they want to do into that workflow as soon as possible, so they don't have to do a lot of turns. And by doing it more quickly, probably something that's going to, increase the speed with which people can use the tool, which means that it's going to be more effective for them. Like another good example of this is Chalmers, which is, we talked about that in the podcast a while ago. It's a chatbot to help people who are experiencing homelessness and connect them with resources. And they found that it was really effective because it was 60 times faster for people to go through this conversational way of finding information and find relevant information than going through a search engine, because it was really targeted to their needs. It was very simple to use. It was extremely accessible, something that the developers were like very, very focused on as they built and continue to build the bot. So I think that's another good example of how, A, the existence of a chatbot can be a nudge, and B, then within your chatbot, how can you make it faster and easier for people to complete the tasks that they need to complete. Right. So let me check the time. Yeah, okay, so we might wrap up here unless there's any other comments. Yeah, I think this was a solid paper, an interesting project, and I think a really nice example of the way that you can have a project that maybe isn't working the way you want it to do and isn't causing the behavioral changes that you want it to cause, and then stepping back and thinking about it and asking for user feedback. That's another thing that I really like about this paper, is that they got the feedback from the users and they looked through it and were like, okay, here's where our bot's failing, here's where it's doing a good job, here's how we could improve it in the future. And I think that's also, sort of like a core design principle here at Rasa, is that your when you're building an assistant, you should, as soon as possible, get it in front of users, get their feedback, see what they're doing with it, and then improve your assistant over time. So yeah. Javi says, my prediction is that apps will be replaced with conversational AI. Yeah, I think some of them might be. I think there's definitely places where it makes sense not to use a conversational AI. So something like a browsing shopping experience where you're like, I don't know, looking for a paint color, for example, I think is probably not going to make a lot of sense to do via conversational AI, and makes more sense to do through a visual interface. But I think a lot of sort of tasks that are done online can be done conversationally if it works, right? It's got to be, cheap and easy for the user. It's got to be consistent. You can't swear at your users. You have to make sure that you are saying things that are true and socially appropriate for the context in which you are deploying your assistant. So, yeah. All right. I think I'm going to wrap it up here. Last stream for a while. There'll be a couple videos that are going up over the holidays here in the US and in Europe. But the streams will be back on January 13th or 14th, that Wednesday. The next one's going to be in office hours with Vova, who I believe we had a reading group with, and he will be back to answer your questions. Vova's great. I think it'll be a lot of fun. All right, so I will see you all then. Have a great holiday, enjoy your new year, and I will see you in 2021. I'll talk to you then. Bye.